Alright, today we're going to be doing some example problems when it comes to operations with polynomials. We're going to be working with adding and subtracting and then multiplying. So our first example here, we're going to simplify this. So what I would do first is I would distribute this -2. So this will become 4, or this stays 4x squared y plus 7x cubed y squared. -2 times that 6x squared y would become -12x squared y. And then this would become positive 6x cubed y squared plus that 9x squared y. So my like terms here, I see x squared y's. Okay, so I've got 4, -12, and 9. That'll just give me 1x squared y. All right, and I also have the x cubed y squares. I've got 7 and 6. That gives me 13 x cubed y squares. All right, example 3, we're going to be writing this in standard form. Standard form just means you go from your highest degree to your constant term. So this is 3x minus 2 cubed. So I do write this out 3 times. Oops. I am going to distribute just these first two together and combine them, and then distribute that last one together. So if I do this one, I've got 9x squared minus 6x minus 6x plus 4. Right, that would become 9x squared minus 12x plus 4. I'm going to bring this one down. 3x minus 2. All right, so I've got 9x squared times 3x, so I've got 27x cubed. 9x squared times -2, -18x squared. -12x times 3x is -36x squared. -12x times -2 is 24x. 4 times 3x is 12x. 4 times -2 is -8. And combine like terms, so I get 27x cubed minus 54x squared plus 36x minus 8. That's my final solution. This one we're simplifying. So we're distributing this. It involves some imaginary numbers here. So I've got x times x gives me x squared. X times -3, -3x. X times 4i, that gives me 4ix. Now I've got -3 times x, that gives me -3x. -3 times -3 is positive 9. -3 times 4i is -12i. And finally, we've got -4i times x, -4ix. -4i times -3 is positive 12i. And -4 times 4i is -16i squared. Now we're going to start combining some terms here. When I do this one, I notice that the 4ix's will reduce down to 0. The 12i's will do the same thing. I've got x squared by itself there. I've got -3x, -3x, which gives me -6x. I've got 9, and it's -16i squared. Remember, I squared becomes -1, so this actually becomes positive 16. So 16 plus 9 will give me 25. All right. Number 4, I want to know if a minus b squared plus a plus b squared equals 24, then what does a squared plus b squared equal? So I'm going to FOIL these out first. So I've got a minus b times a minus b. I get a squared minus ab plus b squared. So that gets me a squared minus 2ab plus b squared. If I do the a plus b, that gets me a squared plus ab plus ab plus b squared. And that gets me a squared plus 2ab plus b squared. That equals 24 here. I'm adding those all together. So in the end, these will cancel. I got 2a squared plus 2b squared equals 24. Divide everything by 2, and I get a squared plus b squared equals 12. All right, example 5. We're going to kind of get back to doing some operations, that function composition that we worked with at the very beginning of the year, as well as with our polynomials. We have our two functions, f of x and g of x. This first one says f minus g of x of negative 2. Another way to write this, remember, is f of negative 2 minus g of negative 2. All right, so I'm going to plug in negative 2 into f. So I've got negative 2 squared minus 3 times negative 2. This gives me 4 plus 6, which gives me 10. All right, and we're going to minus over here. We've got the negative 2 cubed minus negative 2 plus 5. Negative 2 cubed is negative 8 plus 2 plus 5. Negative 8 plus 2 plus 5 gives me negative 1. 10 minus a negative 1 gives me 11. This one with the open circle, that is composition, so it's f of g of x, which means f of, and we plug in g function. And this means for every single x you see in f of x, so for this x and this x, you're going to be plugging in that function there. So I've got x cubed minus x plus 5 squared minus 3 times x cubed minus x plus 5. We're going to attempt this problem. So since it's square, I'm going to write it out twice. X cubed minus x plus 5. X cubed minus x plus 5. And distribute this out real quick. I'm going to FOIL this, so I got x to the 6th minus x to the 4th plus 5x cubed. I'm going to distribute the negative x now, negative x to the 4th plus x squared minus 5x. Running out of room. I'm going to distribute the 5 now, so 5x cubed minus 5x plus 25. Minus that 3x cubed from the very end there, plus 3x minus 15. When I combine all my like terms, I get x to the 6th minus 2x to the 4th plus 7x cubed plus x squared minus 7x plus 10. Ooh, that's a long one. All right, last problem is more like an application problem here. So we've got this trapezoid. We need to find an equation for the area and the perimeter. When it says expression, it's going to have an answer like with x's involved. So you're not actually getting an exact answer. So how this works, we have this kind of go in there. The area formula for a trapezoid is 1/2 the height base 1 plus base 2. So let's plug in what we know. We've got 1/2. Our height here is 3x. Base 1 is 5x minus 3, plus base 2 is this x, the 5x minus 3, and the x, that's 7x minus 3. I'm going to combine some like terms real quick. So I've got here 12x minus 6. I'm going to distribute that 3x through, so I get 36x squared minus 18x. Distribute that 1/2 through, so I get 18x squared minus 9x, and that's my area equation. Now, perimeter is going to be adding up all the outside here. So we are going to need this side, this, and this side. So we have a lot of those already. We've got the 5x minus 3, the x, the 5x minus 3, the x. We're missing those two legs. In order to find those, we're going to do Pythagorean theorem to find them. Because we have those little right triangles there. So I've got 3x squared plus x squared equals, we don't know, so we'll say c squared. 3x squared give me 9x squared plus x squared equals c squared. That gives me 10x squared equals c squared. Take the square root. I get the square root of 10x squared equals c, which would become x radical 10 becomes c. This is x radical 10, and x radical 10. Now to add up the x's, I've got 5x, x, 5x, and x. That is 12x. Plus 2 of those x radical 10s. And I've got